code along with us? Oh, thank you. So let's take a few minutes to set up our environment. Does anyone not have a Google account? All right, we assume that you all have a Google account. And yeah, we're going to paste, sorry, do the participants have the link to the notebook? No? Okay, I'm gonna, so please open this notebook on your computer. So this is actually a file from the AIS GitHub, so you cannot modify it right now. And your first step should be navigating to File, and then save a copy in Drive. So this will save a copy in your own Google Drive. And you can actually modify this copy, yours. Okay, and please let us know if you experience any technical difficulties, or like if you have trouble accessing the link. All right, can I get a thumbs up from everyone whose environment is set up?
So can you say again how we do it?
Yeah, so did you receive the link in the chat?
Yep.
Okay, so what you're gonna do is you're gonna navigate to File, and then you're gonna press Save a Copy in Drive, and it's gonna open a new window where you can actually, it says Copy of Master File, and you can actually modify this file. So you can code along with us.
Thank you.
Yep. You're welcome. All right, so welcome to our first Python workshop in the semester. Also, in the semester, we're going to host a variety of events, including the info session with Accenture. I believe it's on Tuesday next week. And yeah, a variety of workshops. So we are very excited that you attended this one, and we're also excited to see you in the following workshops. And yeah, cool. So this is supposed to be a beginner-friendly workshop, Python workshop. So if you're able to modify this file, please code along with us. Like the code is already written, you're gonna just execute the cells to run the cells to understand what the code does. And yeah, don't hesitate to put your questions in the chat or unmute yourself. And let's start with the first concept. So what are variables? In Python, variables represent values. We can assign various data types, data structures, and even functions to a variable. And variables are also useful. So for example, it is very easy to reference a specific data point through variables, especially when you don't remember what the data is, but you remember the name of the variable, right? So in our first line of code, which is year equals 2022, it means that we are assigning the number 2022 to the variable year, because yeah, this equal sign is basically how we assign values to variables. Yeah. So the process of assignment allows you to store data into your variables. And in this case, we assign the number 2022 to the variable called year. Next, we're going to call the print function, which shows the value that we put inside the brackets as the output. So here the function takes the variable year and outputs its value, which is 2022. Let's run this cell actually. It might take a while. Okay. We can see the green check mark, which means the cell was run successfully. So when we call the print function on the variable year, we can see it outputs 2022 because, yeah, that's the variable year represents this number. Yeah, we can also call the type function. So here we want Python to show us the data type of the variable year. And if we run the cell, we can see that the variable year is an integer. And to sum up, we use the print function to show the output and the type function to show the data type of the value that is stored in the variable. And now I will give the floor to Ari to talk about what other data types you can assign to a variable.
Thank you so much. If you can scroll for me a little bit. Okay, so the first data type that we are going to be talking about are integers. And what is an integer? An integer is a whole number, and it can be either positive or negative. Let me just admit some people coming in. So for example, here, as you can see, the first line of code, apples is our variable, and it will be equal to 15, and that is our integer. And then on the second line of code, we have print, we have apples. So on we have, that is printed literally. And then comma apples will bring the integer 15 on our output. Moving on. There's another example. So basically, if we have 5 more apples from the store and we want to add, if we buy 5 more apples, right, we will have to add that amount to our total. So here we have apples equal 15 plus 5. And as you can see on the print line, after buying 5 more apples, we have apples, which will be the calculation made inside of the variable apples, and then apples. And then your output will be, after buying 5 more apples, we have 20 apples. Okay, the next is simple. If we ate 1 apple, we will have to subtract from the amount of apples what we currently have, right? So apples is equal to 15 minus 1, the same concept when you print the sentence and then you bring the variable inside of the sentence, then you will have a different integer when you made the calculation. So it will be changed. Moving on. If we share our apples between 5 people, we want to divide the amount of apples by 5. So apples equal 15 divided by 5. And then it's just the same concept. So you see how we are assigning a new value to apples, and that is going to change the integer when we make the calculation. And basically the output will be, after sharing 15 apples between 5 people, we have 3.0 apples left. But this is there's something that you have to pay attention to. The reason why we see a 3.0 instead of a 3 as an integer is because the division operator will always return a decimal number. But this could be fixed. This can be fixed, and I will show that in the next example. Yeah. So here, If we wanted to divide two integers while ignoring the decimal places, we will use the integer division operator. And here you can see how both operators work differently. Apples equals to 15. So in the first print, we have only one division operator. And then on the second one, we have the integer division operator. And you see how our outputs are different because the first one is a 3.0 and the second one is 3. Okay, moving on. Okay, if we have an integer that is not perfectly divisible by the divisor, using integer division will ignore the remainder of the expression. Yeah, basically the same concept. Apples equal 15, print apples divided by 10. The first one will give you 1.5, but the second print line, yes, the second print line will not show 0.5. It will not show the remainder. It's ignoring the remainder. Okay, yeah, moving on. If you guys have any questions, feel free to stop me always. If we want to know what our remainder is from division, we will use the modulus operator, which is a little bit different. Apples equals 15, right? We know that apples equals 15. So our first print, we're just doing a normal division. 15 divided by 10 will be 1.5. And then something here, it's a little bit more different. Apples is being divided by 10, but it's not showing what it could be divisible to. It's showing the remainder of the division, if that makes sense. Okay, 15 equals 10. 15 equals 10 plus 5. Okay, all right, moving on. So we also have exponents in Python. If we want to implement exponents, we will use the exponent operator. Here, apples is no longer 15. It is equal to 100. And our first print option is apples. So what is happening here, we have 100 squared on the first one because apples equals 100. So it's 100 squared. And then on the second one will be 100 exponent 0.5. And that's why we get 10. Okay, if that makes sense. Okay, the second data type that we are going to be focusing on today is floats. And what is a float? Well, floats are floating point numbers or real numbers that are written with a decimal point. And here I have an example. Money equals to 13.05. And then we have a print that says we have, and it brings the variable money. We have 13.05. Also notice how the second line of code, the third, print type 1305 gives us the output of class float. And it's just basically telling you what data type 13.05 is. Okay. Floats and integers have similar operations as well. Here we have addition. There's several examples with addition, subtraction, multiplication, division, integer division, modulus, exponents. So basically what we just covered in one cell. So we have different examples so we can see how they work, right? On the first one, we're just adding 2.34 plus 3.45. And on our output, we can see that that's equal 5.79. Let me just admit. some students. Okay, and then we have subtraction, we have multiplication. Notice how, this is something you have to remember. Multiplication is 1 asterisk. Multiplication is 1 asterisk and exponents are 2. So we're clear there, okay? And then we have a division, and then we have integer division, the modulus, and then the exponent. Oh yeah, exponent is right. Exponent is there. Okay. Yeah. So when you run all of these examples, these are the outputs. These are the outputs that you get. Okay, so if you guys have any questions, please feel free to leave them in the chat. Okay, now we have a different data type, and we have here strings. But what are strings? Strings are a collection of characters, specifically Unicode characters. Also, something very important is string must be encapsulated with quotation marks. It could be single or double. For example, the first example is print hello world, the one that everyone knows, right? You can see that here we're using double quotes, but you can also use single quotes in print hello world. Yes, on the second line of code, we have print type. I love A's, right? We love A's, of course. And what that will give you, the output will be just specifying what data type it is. So you can see that below the output hello world, we have class string. So that when you use the type function, it will show you the type of the data type. Also something that we have to remember, for example, the third line of code, print type Baruch students are smart. You can see that students have a apostrophe, right? So you can print a sentence and words that have apostrophes, but you have to make sure that inside of the sentence or the word, you have to use double quotes. That way, Python understands that, oh, she's trying to, or him trying to, they're trying to print this whole sentence, but there's an apostrophe in the middle. So that way Python doesn't get confused on what you're trying to do. Yeah, it wouldn't include it, as you can see if you change it. Okay, that makes sense. There's a question. Yes, it also tells you if it's a float, it's an integer, it will specify which data type in general. Okay, that's a good question. Moving on, I think that's pretty clear. Yes, that is a good question, the F1, right? We will see that later on. So let's not forget that question because we will cover that just in a second. The next example. String operations perform differently than integers and floats. So here, what's happening here is that I have two variables, right? I have variable A and I have variable B. And A equals to I love and B equals to dogs. So something that you can do is print A plus B, and it will give you the output I love dogs, as you can see at the bottom on the output. Also, something that you can do with strings is a repetition, which is basically you using an asterisk or a multiplication symbol, and you multiply by a number, and that will repeat the same word or the same sentence, the same string. As you can see at the bottom, I love cats, I love cats, I love cats. We all love cats. Okay, moving on. Yeah, that's pretty simple. We're just multiplying I love cats by 3. So the next one, I love cats, I love cats. Yeah. We all love cats. Okay, the next one. I don't own a cat, unfortunately, but I would like to. Yeah, we'll see. We'll see in the future, though. Okay, so there you go. There you go. There's the answer. Okay, but we will also see examples with that in a second, in case you're still a bit more confused. We also use string formatting to make string efficiently. We can do this. Oh, there's right there. Okay, so name. Yeah, let's go through this real quick. Here I have two variables, right? I have name and I have age. Name equal to Fluffy and age equals 4. Even though both sentences are the same, it is better to use F strings when inserting variables into strings. And you will see why, right? I feel like it's less complicated. It's less things that you have to add. So I have two more variables, right? At the bottom, I have all sentence, right? And then I have new sentence. So you can see how both do the same work, but you can do it differently. On my old sentence, we have my cat's name, and then we use plus sign name, plus sign, and then another part of string as she is, and then plus sign, and then string in parentheses age, and then plus years old. And when you print all sentence, you will get my cat's name is Fluffy and she's 4 years old. And then on the second variable, new sentence, this is how you can do the same thing without having to add so many components, right? So we use new sentence equals to, here we have the F string, right? And then I have my sentence, you know, what I want to say, my cat's name is, and then instead of using plus signs, here in this example, we're using curly brackets to insert whatever we stored on the variable name. And then as she is, age, curly brackets, 4 years old. And it's the same thing, it's just different ways to do it. But, you know, now we have F strings, which are better inserting variables. Hope that makes sense. Okay, our fourth data type are Booleans. And what is a Boolean? Well, Booleans are logical data types that can only have values of true and false. So here is just the basic example showing you how when you print true and you print the data type, the output will specify that it is a class Boolean. On the first line of code, we have print true, and then on the second, print type. And as you can see on the output, it will tell you whether it's a string, whether it's the integer. But here, since we printed true, it's a Boolean. And now below this, we have more examples that we can understand what's going on. Yeah, so we know that Boolean expressions are evaluated whether they're true, whether they're false. So my first example with the equal operator, this is basically just saying print 1 equals 1. And my output will be true because we know, of course, that 1 equals 1. And then on my second line of code, I have print is not equal, right? Not equal operator. 1 is not equal to 1. And since we know in English, right, that 1 equals to 1, my output will be false. The third one will be 1 is greater than 1. That is false. 1 is less. There's a question. Yeah, that's the not operator. That's the not operator. It's like you saying this is not equal to. I hope that makes sense. Saying 1 is not equal to, and since we know 1 is equal to 1, it's false. There you go. Okay, you got it. Okay, one is less than 1, and then we have 1 is greater than, equal to 1. That is true because it's either greater than or equal to. And then the last one, we have 1 is less than or equal to 1, and it's true. So that way you see how they work, right? So here we have logical operators and conditional statements. We have 3 different ones, right? We have the and operator, or operator, and the not operator. So here we have true and true. When you have when you have both sides being true, you will get output true. And then when you have true and false, your output will be false, because think about it like this. On both sides, there is a side that is false. It is not completely, it's not entirely true with the and operator. Because with the or operator, it's different. So when you have true and false, that will be false because you have one side being false. So you will get false. And then the third one will be false and false. Well, everything is false. So you will get false. Then after that, we have the or operator. And then the first one is true or true, and you get true. On the second one, we have true or false, and you still get true. And for example, you can think about it of like 1 is equal to or greater than 1, and that is true. So you see how like in that statement, even though greater than is false, but you have also or equal to, it will make that function, the print, be true, because there's a possibility for it to be true. And then on the third one, we have false or false. And since everything is false, you will get false. Now, the last one is the not operator. And it just changes to the opposite, basically. Print not true, it will give you false. Well, if it's not true, it's because it's false, right? And then on the second one, we have print not false, and you will get true, because obviously, if it's not false, it's true. I hope that makes sense. It's like gibberish. Okay, so it was fun. Now I will pass it on to Natalia.
Thank you. So moving away from data types, but still staying on the topic of logic, let's discuss if statements. What are if statements? If statements are conditional statements, and we basically tell Python, if this condition is met, then do this. And if we want our code, this one, to be dependable on the condition specified in the if statement, here, we need to also not forget about indentation. So if if this line of code didn't have indentation, it will be 2 independent lines of code. But yeah, we need to indent it using the tab. Yeah, and yeah, so here this also utilizes Boolean expressions. If 1 equals to 1, which is always true, Python will execute this code. So Python will print the statement is true. And here, if 1 doesn't equal to 1, this condition is always false. So this line of code will not be executed, and Python will not print this sentence. As you can see, there is no output. Yeah, the else keyword is an optional statement that catches anything which isn't caught by the preceding conditions. So yeah, if here we can see if 1 equals to 1, we print the statement is true. And yeah, basically Python stops here because the condition is already met, like it doesn't need to go to the else statement. But if it were, for example, this, if like a false statement, then Python will not execute this line of code, and it will jump to the else statement and execute this line of code. Let's run this cell. The statement is false. The output changed to like another sentence. Okay, and again, yeah, this is the same. This is the same code basically. So yeah, we will use if-else statements if we want to test our code for two conditions, right? But yeah, but what happens when two conditions are not mutually exhaustive, right? What if there are multiple conditions, right? Then we will actually use the if, else statements, which is basically translating it to English, it's if this statement is correct, do this. Else, if this statement is correct, then you should do this. And so on. You can add multiple conditions, and the last condition should be always a else or else if. So let's run this cell. Yeah, so all of the conditions, all of the three first conditions were not true. So Python jumped to the last else statement and printed cat doesn't equal to dog, bird, nor chicken. Okay, and once again, please don't forget to use indentation, because this is very important. Because if we don't use indentation, let's see what happens. We'll probably get an error, but yeah, we will get an error. Okay. Perfect. And we have previously touched upon variables. This real quick. We have previously touched upon variables, and for recap, they can be of any data type. So a variable can be a float, a string, an integer, etc. And the left side is the variable, and the right side is the value we want to assign to the variable. But there are also a few rules when you initialize variables, and they are listed here for your personal reference now that you have the Python notebook. So the first rule is that you don't make variables keywords. So your variable should not be called if, else, return. So if you see that your variable is any color of the rainbow, basically, or whatever Python uses, it's probably not a good name. Like it should be plain text, the color of plain text, like in the output. Yeah, and you can look up the list of Python keywords for more examples. And also, the second rule is your variable name must start with a letter or an underscore character. So you cannot start your variable with a number, because that will result in an error. Third, make variable names that make sense with what's being assigned to them. This will not produce an error, but it's just a best practice. So if you're trying to store like the closing price of a stock in a variable, then your variable should probably be closing price or something like that. Yeah, so if you don't remember the data point, you can, you always remember the variable name. Fourth, variables are case sensitive. So apple that starts with an uppercase A is not the same as apple that starts with a lowercase a. And we can also prove it using Booleans. Hold on. Oops. Also, yeah. So it is case sensitive. Also, a variable cannot contain spaces. So that's why we have underscores, right? So if you really need like to separate words and you don't want to do something like this, so like you don't want to have capitalized letters for some reason, you can use underscores. Yeah, and here's an example of initializing variables. So here we assign the string red to the variable color. And when we print it, when we print color, we get red. And it's a string. And obviously, after we initialize the variable, we sometimes have to redefine it and assign a new value to it. And a good rule of thumb is to stick to the same data type. So here we change the variable color from red to blue, right? And but it's not preferred to change it to a number. So this would work, and now the variable color represents blue, and it's a string. But if we want to change the value of color to like a 25, it's kind of tricky. There are better ways to do it. So even though this will not result in an error, it's not preferred. So don't do that. If you want to change one data type to another, we can use casting methods, right? Basically, we encapsulate the value into a function that consists of the name of the data type that we are trying to change the variable to. So here we have the variable oranges, and we assign 5 to the variable oranges, right? And for now, the 5 that the oranges represent is an integer. But maybe, maybe we want to make an orange juice and we also need to cut the oranges. And it's crucial for us to, have the oranges in like halves. So we use the casting method to redefine the variable, and now oranges is a float. So it's 5.0 and class is float. Yeah, so let's say for some reason you also want to use oranges, the value that oranges represent in a sentence, but you forgot what an F string means. And you need to, how do you say it? Basically, you need the 5 in like a string format. So once again, you encapsulate 5 in the data type that represents string, and you get a string. And with Booleans, it's also fun. So as long as like you can encapsulate in a Boolean any value, but as long as it's not 0, none, or like a blank space, it's always going to be true. It's going to output true. And yeah, let's run this up. Yeah. So if you want to if you want to test none, 0, or like an empty space, it's always going to result in false when you try to redefine the value. redefine the value to a Boolean. Okay. And also, casting does not work for conversions. So you cannot. So if you have a string, right? The string in this case is hello. You cannot make an integer out of it. Like, it's not logical in my head, and Python also doesn't know how to do it. So this will result in an error. And also, the same string, you can also not convert it to a float because there is no number in the string. So this will also produce an error. What you can do is, if a string itself represents like a number, right? Then it is possible to convert it to an integer or even a float, right? So here we assign, here we take the string 42, we convert it to the integer and assign it to the variable x. And then when we print the variable itself and its type is going to say 42 and class is integer. And the same with float, right? Here we can see that the string itself is a float, so 37.45. And yeah, we make the string, we convert the string to a float and assign it to x. And then when we print x and the type of this variable, we will see also, like, this is a already known result. And this will not produce errors. All right, moving on. Input and print functions. So you're already familiar with the print function. We're going to discuss basic parameters of the print function in this section, but input is more fun. So input functions allows a user to input information into the program, like into the output. And here the function, if we run the cell, here the function asks me to enter my name in the output. And through the input function, we will be able to take this information. Oh, sorry. The cell is still running. And as you can see, the output produced a string which says, yeah, Natalia K. And yeah, so through the input function, we'll be able to take this information, assign it to a variable, and then do something with that variable. For example, we can use it in another function. Let's take a look at this example. So this code also asks for the user input. And then when we enter our input, it's gonna assign the input to the variable called name. And then we're gonna actually use this variable in another function, which is print. So we're gonna print a string and use the variable that contains the input. So here's a demonstration. Okay. See, this code produced the string, "Hi, my name is Natalia K." Moving on, the print statement above, yeah. So this print statement above uses concatenation to combine the elements, as you can see from the plus signs. And this is also why we need the space right here, because if there was no space, well, there wouldn't be a space here. Let's try it out. See. All right. Yeah, and you can also only concatenate a string with another string. So, for example, if I want to combine a variable that holds an integer with a string, it will give me an error. So this is useful. We can see how f strings are useful here, right? Because this will result in an error. Right? And you can get around this by turning the element into a string. what we did in the previous section in the variables. So when we convert the integer to a string, we can concatenate it with another string. But again, it's also important to include this space. So this will not produce, this output is okay, basically. Yeah, you can also, if you don't want to use the plus operator, so if you don't want to concatenate the string with another string, you can change the print function's parameters. So you can actually do it with a comma. Yeah, we assign the string row college to the variable called college, and we print the value that college represents, which is the string row college. And then we also print is the best QU. And it will be all right as well. So here you don't have to worry about the extra space. And yeah, there yeah, you can also use the sep parameter to change how to separate each value. So if we print the first line of code in the cell, we're gonna end up with numbers 1 through 10 that are separated by a single space. And if we look at code line number 2, we will see that there's an additional parameter, sep, which we can add, and we can define how to separate them if not, if we want them to be separated through anything else other than space. So here we add a comma plus a space. And this is our output. Yeah, and we can also separate the numbers with actually anything, any other character. So instead of the arrow, we can also, now instead of the comma, we can probably do the star, the asterisk. Yeah, the asterisk. And it's gonna work. Pretty cool. Okay, and if you're confused about a function, just print this line of code, type this line of code, help, and the function name in the brackets will give you additional information about the parameters that you can use with this function. So here you can see the print function could have additional parameters, which are file, sep, end, and flush. All right, so moving on to data structures. Data structures are generally used to store more than one data point, right? So it's gonna get more complicated from here on, because previously you've only worked with integers, floats, and strings. And this is data structures are used to store, well, more than one data point, right? And I would like to pass it on to Ari to introduce our first data structure, which is lists.
Okay, I'm back. The first data structure is going to be lists. And what is a list? Well, a list is a mutable data structure that is used to store collections of data and is ordered using indices. So here we have to pay close attention to our index, right? And also something that you have to remember is that we use square brackets for lists, and you will see why it's important to distinguish this, okay? So basically here we have variable characters, right? Characters equals to square brackets, and we have SpongeBob, Patrick, Sandy, Squidward, Plankton, people that we know, right? People that we know from before. So characters equals to my list. This is going to be my new list. That's my first line of code. My second line of code is something that we already covered, which is print type. And this will also bring back and tell you, well, this is a class type. It's going to tell you the type, right? So now we know we're going to be working with SpongeBob characters for this part of the code, okay? So next, lists don't need to contain the same types of data. So here I have, this is just like a side note for us to remember, right? Unknown is my new variable. It equals to SpongeBob 1, 2, 3, 4, which is a integer. And I have true, which is a Boolean, right? So we have different types here. It's possible. Okay, let me just keep moving on. Okay. Yeah. No. It's not supposed to be like that. There you go. So here we're just going to print our characters and see what we get. Here I do print, and I print my variable characters where I stored my new list. And below that, I also printed the type. So it specifies what data type we're working on. And well, we're working with a class list, okay? So after this, we're going to touch upon the indices, right? Something that I mentioned. So here's an example. This is how we're gonna go about this. Alphabet is my new variable, right? And this is basically a new list. My alphabet A, B, C, D, E. Not the entire alphabet, okay? It's just to E. This is just to show you the index, how index works, okay? So we see that on top of A, variable, my element A, we have 0 and -5. So even though my element A is the first one, its index is not 1. Its index is 0. It could be 0 or it could be -5. And here you can see that my element V, the second element, has index 1. So if you are trying to print an element from your list, you can use index, as you can see below. Print alphabet 0 and alphabet 4. It brings the letter A and E. You can also do negative numbers. And something that you can think about of negative numbers, like why would you use negative numbers? Well, imagine if you have a list with a lot of elements and you don't know how many elements you have. A way for you to bring the last element of your list is using -1, which would be the last index. As you can see on top of E, we have 4 and -1. That's just a way for you to think about, like, why would I use negative index? Well, that's a way to ease your work, right? Okay, moving on. I hope that makes sense. You can stop me if it doesn't. Let's bring back the characters that we know, right? We have characters and we have the squad, SpongeBob squad, right? I'm going to print my characters. That is my second line of code. And then I have print characters 0. You see on the second output, I have my list, and then I have SpongeBob. SpongeBob has index 0. And then, oh man, I wanted to ask a question about this, but I already showed the answers. It's okay. It's okay. I was going to ask, like, oh, if I do print characters 4, which character is going to come out? But it's already there, so I can't ask that.
Mr. Krabs' nemesis Plankton?
It's right there. That's cheating. Okay. So yeah, this is basically how we want, if we want to bring an element, a specific element from a list, we can use index. Okay, let's move on. Now, if you don't know, yeah. Now, if you don't know the index, like the location of, hold on. Another way we can access elements is through slicing. We can achieve this by using a column. there is a special case we most note of when slicing lists, the index number we put after the column. Okay, so this is what's happening here. Characters equals to all my characters, right? And I want to bring several of my characters inside of the list, right? I have print characters. Okay, I have print characters 1 and 5. So if you look at the list, SpongeBob is not included because we don't have, we're starting from the index 1 and we know that SpongeBob has index 0. So we'll bring Patrick, Sandy, Squidward, and Plankton. Notice also how Mr. Krabs is not included, right? But we have from 1 through 5, right? So that is what you have to note. This is something you have to remember. When you're doing slicing, you will include the 5th index, but it will not print because Python will grab all the elements up to, but not including the index after the column. This is after the column only. So in this example, you see from 1 through 5, the 5th index is not included. Plankton, which with index 4 is the last one that gets printed. Okay, I think that makes sense, right? If it doesn't, you can stop me. Okay, moving on. So this is another way to print your entire list. Characters, we have my list here, right? I have on the second line of code, print characters, and I only have a column. Basically, this is just telling Python, listen, I want the entire thing. Give me the whole thing, right? We're only going to use a column and it will print back all the elements inside of your list. Okay, moving on. Okay, so here, if I wanted to get all characters from Patrick and the elements after, we can specify only the left bound. So what's happening here is I'm telling Python, I want from index 1, yes, from index 1 till the end of the list. And here, as you can see, our output from print characters 1 column space blank, it will give you it will give you from Patrick till the last element of your list. So just if that's something, if you want to put it on your notes or something, it's really helpful. Yeah, and next, yes, if I wanted all the characters before Sandy, I can specify only the right bound. Yeah, so here, remember that the right bound is something that we have to constantly pay attention to, right? Like I said, the right bound, even if you include the index, that specific index will not be printed. So here we have from SpongeBob to Patrick, but we know that Sandy was not included, right? And it has index 2. So here, basically, Python is just taking everything from the beginning up to Patrick with index 1. So that's just another way for you to get slicing. If you just want a specific part of the list, oh, I only want the beginning of the list up until here, that is a way that you can do it. Okay, moving on. Okay, there is a third parameter to slicing that exists that allows you to skip elements. Oh, yeah, yes. We also can skip elements. So on my second line of code, I have print characters and I have only a column, right? This is only printing my entire list, the entire list. And on the third line of code, I have print characters, empty space. I have 2 columns, and then I have a 2 on the right side, right? So what this is doing is like, it's just taking the whole list and it's skipping by 2, right? Starting from SpongeBob. Yeah, so if you start from SpongeBob and you do 1, 2, Sandy will be picked, and then 1, 2, Plankton is picked. You see, if you start from SpongeBob and then skip Patrick, go to Sandy, skip Squidward, go to Plankton, and since we don't have anything else, Plankton is the last element that gets printed. It's just jumping by 2s. Okay. Okay, this is just saying lists are really good to use because they are mutable. And that means that you can change the data within the list. If you want to remove Plankton, if you want to remove SpongeBob, it is possible. Okay, all right, sorry. Yeah, it is possible to change the elements within a list. So this is how we do it. Yeah, so I have a before and an after output, right? So this is the first output. The before output is what we had previously, right? This is my entire list. This list is not being changed. The second output, we see that we are missing Plankton, right? We replaced Plankton with Gary, sorry, not Gary. Yes, on the third line of code where it says Gary eats Plankton, we have characters and then we specify the location where we want to, yes, add it on your notes. Characters, and then we have the index, which is the location that we want to add this new element. And we know that Plankton is the 4th index. And we now want Gary. So see how I am assigning Gary to that specific index. And then when I print, I get Gary instead of Plankton. He's probably just stealing the secret formula. Okay, we no longer have Plankton. Okay,
All right, I'm gonna talk about the methods. So list methods are methods that are built in by Python and they're usable for all lists. And there are a lot of methods for lists, but let's go over the most common ones, right? So yeah, here you can see our list of SpongeBob characters, which we will once again be working with. We assign this list to characters, and then for reference purposes, let's print the characters. So here's our list. Okay, the first method is append, right? Ari already talked about replacing elements in a certain index in the list. And we can also add an element at the end of the list. So the list can expand, basically grow. Here's our original list. And now, by the way, here's the syntax for the methods. Basically, we first start out with the data structure, which we're trying to apply this method to. Then we type a dot, and then we print append, in this case, or whatever method there is. Then we specify what is it that we want to append within the brackets, right? So here, in this line of code, we want to append Larry, the string Larry, to the list of characters, right? And after we print it, we can see that Larry appears on the end. So it was added to the list, and now the list looks like this with one more character, right? Yeah, but it's always going to be appending from the right side, so from the end. Next, the pop method. It allows you to remove an element, right, at a specified index. So let me go to this one real quick. You might be like not too familiar with the indices, but we usually start at index 0. So that might be a challenge that you will need to adapt to. So, okay. Again, here's a list, and now we want to basically remove the element that has the index 4, which in this case is going to be plankton. We do this the same way, like the same pattern. We type out our list, then dot, and our method, so pop. And in the brackets, we specify the index. And we assign the new list without the removed element to the variable popped. No. Sorry, excuse me, my bad. We assign the element that was removed to the variable popped, right? So the list is only going to change that plankton will be removed, as you can see here. So after we apply the pop method, we can no longer see plankton. But when we try to print the variable popped, that's where we can see plankton. Cool. Yeah, the index method. It allows you to find the index of a specified element in the list. So here you actually don't have to remember the indices. Once again, we have the list, and we have the characters. And yeah, by applying the index method to the list characters, we basically tell Python to find the index of this element that we include in the brackets. And just a friendly reminder, this is a list of strings, so please include a string in the brackets because, yeah, data types. Anyway, and we assign the index of Patrick, which we right now don't know, but we assign it to location, right? And then when we print location, it's going to give us index 1. So now we know that the value, the element that has the index 1 in the characters list is Patrick. So yeah. Okay, next, the sort method. It allows you to sort the list. Yeah, so here we don't have to include any parameters. I believe, hold on. Oh no, okay. I forgot the syntax. My bad. So, yeah, we don't have to add any parameters. And what this method is basically gonna do, it's gonna sort our list in a, I believe, ascending order. Yeah, like in alphabetical order. Cool. And there's also the sorted function. So it's kind of different because when we use the function sorted and apply it to the list, our original list, right? And then we assign the result to the variable new characters, we will actually get the same result, basically. Yeah. So the sorted, it's not a method, I believe it's a function. So the sorted function allows you to sort the list, but it doesn't affect the original list. So this is the key difference, right? It doesn't affect the original list. So after we applied the function to our list and assigned it to the new character, our original list stays the same. So when we print it in our 4th line of code, right here, it is still gonna resemble our original list. But when we print the variable new characters, which has the value of the sorted list, it is now a disordered list. There's also the reverse method, which allows you to reserve a list. There's also the reverse method that allows you to reverse a list, meaning the last element will become the first element, and the elements with the index 0 will go to the end of the list. So same logic. You kind of apply the method to the list, to the variable that represents the list, and you print it out. And as you can see, it indeed reversed the original list. Yeah, and another thing, like this is not considered a method, but you can also use the plus operator to combine lists. So just like we concatenated strings, we can combine lists. So here's an example for that. We assign to variable A the following list of 3 characters, and another 2 characters are being assigned to the variable B. And then either we can print like one list plus another list, or variable A plus variable B. The output is going to be the same. It's going to be one list, not like 2 separate lists. Yeah, and once again, I'm gonna pass it on to Ari to explain our second data structure, which is tuples.
Okay, I'm back. The second data structure that we are going to be covering are tuples. And what is a tuple? Well, a tuple is an immutable data structure that is used to store collections of data and is ordered using indices as well. So here, remember how I said that when we are working with lists, we use square brackets. Now with tuples, we have to use parentheses. So that's why I said, oh, okay, we have to remember this, right? That's like the distinction between them. So here we're gonna create a tuple. Characters, characters equal inside of parentheses is basically the same information we had previously, but this is a tuple instead. Yes, thank you, Cheyenne. Thank you. And then on our second line of code, we do print characters, and well, we will get our tuple, right? Moving on. We can extract data from tuples like we did previously with lists, right? We also work with indices. We also work with indices, and it's basically the same idea. We have SpongeBob with index 0, and then we can also do slicing with the column, like on the 4th line of code. As you can see, also, Mr. Krabs has a negative index, and you can also bring them, but you have to use square brackets. You cannot use parentheses for the index if you want to bring the index. Just basically the same idea, but with tuples. Okay, moving on. Okay, this is very important if you guys want to put it on your notes. Tuples are different than lists because they are immutable, right? Which means we cannot change the elements within the list. And so we have an example here, characters, that's my new tuple, right? And then I'm going to try to change plankton for Gary, like I did previously, right? But sadly, Gary cannot eat plankton this time because it's a tuple and we cannot change it. Okay, we will get an error if we try. Okay, and now I'm going to pass it on to Natalia.
Thank you. Great explanation. So since tuples are immutable, they have limited methods, right? This is why this section is so short. And one method that I'd like you to know is the count method, which returns the number of times a specified value occurs in a tuple. So here you can see the code for that. So yeah, we have an array this time, which is similar to tuples, I guess. And yeah, we're going to apply the count method to the array. And this time we're gonna look for the number 1. How many times does number 1 appear in this array? So when we run this cell, it turns out that 3 times, right? There are 3 ones in this array. Okay, and the index method allows you to search for the first index of a specified value in the tuple. So here, same array, right? 3 ones, 2 twos, 1 3, 1 4, and 1 5. And when we want to find the first index where the number 2 occurs, even though there are like 2 number 2s, it still will return the index of the first one that it finds in this array. So if we run it, it's gonna return the index 3, right? Because we start counting from index 0, then 1, 2, 3. Cool. So one thing I also want to mention is why would we use tuples instead of lists? So tuples are more memory efficient than lists because they are immutable. So you cannot change the length of it. You cannot add elements. Yeah, and they are also easily accessible. And I'm gonna pass it on to Ari to talk about our next data structure.
Okay, so our third data structure that we will cover are sets. And what is a set? Well, a set is an unordered collection of items where every element is unique. And we use set parentheses function to initialize a set. Yeah, so we will have to use that first in order for it to work. So here we have cards equals to set parentheses. So basically what Python is doing is creating an empty set so that then you can add to it after. On the second cell, it says we can also initialize them by using set function on a list or by populating curly,
Curly brackets.
Sorry, I just got a message. I'm sorry. Yes, curly brackets
yes.
with values. Well, 1 second, let me just reply to this. Okay. All right. So yeah, I'm sorry about that. Like I was saying, cards previously we said it was empty, and now we are trying to add a list to it, right? And then when we set that new list and we print cards, we will get the output of the list and the values that we want within. On the third line of code, we have cards with curly brackets, and it's basically doing the same, basically doing the same thing as previously. All right, that was very short.
Yeah. Well, sets are, as our director of software engineering defines it, sets are one of the most important data structures in Python because they only contain unique values. Yeah, and the add method allows us to add an element into the set, right? So here we initialized a set and assign it to the variable cards. So cards now represents this set. And yeah, here's after we print the variable cards, we can see the output. But if we want to add a value, and in this case, we are adding the value 5, after we print the variable cards, it's still gonna have the same output because the values in the elements in the set should be unique. So if we change it to 6, let's say, and we run it, the second set will have the output of like +1 element. And the remove method allows us to delete an element from the set. So here, once again, we have our familiar set, and it's assigned to the variable cards. And we want to remove the element 5, right? And when we run the functions, when we apply the method to the set and we remove the element 5, after we print the set out, it will have all the elements except element 5. So pretty straightforward. Also, sets are also important because they apply directly to set theory, and set theory is a branch of mathematical logic. The difference method returns a set that contains the difference between 2 or more sets. So here we have 2 sets, set A and set B. Right. And if we want to find the difference, so you can find the difference between A and B, but there are 2 ways to do it. So if we want to know what values are in A that are not in B, so what values are unique to A that cannot be found in set B, we use this method. And after we print it out, it indeed turns out to be 1 and 2. And if we want to know what values are in B but are not in A, we can use this method. Basically, the variables here are like turned around, basically. So here we apply the difference method to the set A, and here we apply the difference method to set B. And the elements that are unique to set B is 5 and 6, because 3 and 4, you can find them in both sets. Moving on, the intersection method allows us to see what 2 sets have in common. Here the order doesn't matter. You can actually change the variables, I believe, and it will still have the same output, which is 3 and 4, because those 2 sets share those elements. You might be a visual learner, so if you have like a piece of paper and a pencil, you can draw like Venn diagrams if you want. Another method another common method that is applied to sets is the union method, and it returns the union of sets. So all the sets combined. No, wait, it combines 2 sets. Here the union method adds the elements of set B to the elements of set A, but I believe it's kind of tricky if we wanted to change the places of the variables, because elements in a set are ordered. But let's see what happens. Oh, no, it doesn't change. Okay, never mind. And there are many more methods other than sets, but these are the most common ones. And once again, I want to pass it on to Ari to talk about our last data structure, which is dictionaries.
Thank you so much. Now we're going to be covering dictionaries. Dictionaries are used to store data values in key value pairs. That's something that you should definitely put in your notes if you want to. The key column value pairs. Dictionaries are initialized using curly brackets or the direct and then parentheses function. So we are going to be working, we're going to go back to the bikini bottom characters, and we're going to create a new dictionary. So citizens of Bikini Bottom had a Krabby Patty eating competition. Let's use a dictionary to see how many patties each character ate. So this dictionary, I am saving it, I'm storing it, right, on patties, right? I'm assigning that to patties. Patties equal to, and this will be, this is now my new dictionary. So my first key is SpongeBob, and the value is 5. And then my second one is Patrick, and Patrick ate 15. And then Sandy, she ate 3. Then keyword 100 was hungry. And then Plankton only ate, well, that makes sense since he's so tiny. And then Mr. Krabs only ate 2, even though he's the owner. I would have eaten more, but that's okay. This is our new dictionary, right? We can also display dictionaries in this way, which is more common to see in the industry. And also I feel like it's easier on the eye. That way you see which key and value is assigned to which, right? It's just a different way to print it. Definitely. Okay, moving on. Yes, if you want to get a specific value, you must use the appropriate key. So if I would like to know how many patties Squidward ate, I will then do print patties, and inside of square brackets, I will include the key to get the value. And then when we print that, we see that Squidward was very hungry because we get 100. Okay, and then let's find the amount of patties that were eaten by Larry. Let's do the same thing. I want to know how many patties Larry ate. And here we can see that we get an error, and this is because Larry is not part of my dictionary, right? He is not. Okay, we're printing patties. Yes, as we can see, Larry. Yes, living like Larry. As we can see, Larry, sorry, Larry is not on the dictionary, so we will get an error when we print it, which makes sense, right? You're trying to look for Larry, but he's not there. Okay, moving on. This is a way we can fix it, right? There's a way we can fix this. Larry did not compete in the competition, right? We will get an error because of that. To avoid getting errors about invalid keys, meaning keys that we do not have, we can use the get parentheses method to bypass this. So first we will do print, and then we will do patties, where is the variable where I have my dictionary. Then I will do dot get and then parentheses. And I will include Larry, which is my new key, my new element on my dictionary. And then after that, I will do, to add a record into a dictionary, we can use a new key and assign it to a value. So because I want Larry to be in the competition, I also have to include how many patties he ate, right? So here I'm doing print, and then before patties, this is just to show the old dictionary before we made the change with Larry, right? And then on the second line of code, I do patties, square bracket, Larry, and I'm giving him the value. So we know that Larry is my new key and 10 is my new value added to Larry. And so then when I do my print and I do patties, we can see the change, right? We can see how now we have Larry competing, but I guess he didn't win because he only ate 10. Okay, moving on. We can also delete a record from a dictionary, and we can use a del keyword, the del, right? Let's say SpongeBob was caught cheating, and he was disqualified because you can't cheat, right? So on my first line of code, I'm just basically printing my previous, well, not the previous, the newest change of the dictionary, right? Because we can see that Larry, it's part of it, right? Because we added Larry, right? Okay, so I have my newest dictionary, and then I'm going to make the change because I'm going to delete SpongeBob because he cheated. So del patties on my second line of code, I have del patties, and I have square bracket SpongeBob. And this is just me telling Python, I want you to delete SpongeBob. And then when we print, after that, we can see on the output that we no longer have SpongeBob participating. Okay, so moving on. To change a record from a dictionary, we can reassign the value using the key. So let's say Patrick actually ate 20 patties instead of 15. I can change the value for him, right? On my first line of code, again, I'm just printing my dictionary. With the new change, we can notice that on my output, SpongeBob is no longer with us. My second line of code, I have Patrick, which equals 20. And then I'm telling Python, okay, for Patrick, it's no longer 15, okay? It's 20. So you can see how before and after, yes, there's a 20 on the after, and there's Patrick 15 on before. That's how you can change the value. This is just a side note. To see all the keys in your dictionary, we can use keys parentheses function. And so my first line of code, print patties.keys parentheses, and it will show you your actual keys. Like it will not include the values. It will only show you the keys that you have on your dictionary. And then, but if you want to also see the values, you can do the same thing. Basically, is print patties.values parentheses, and you will get the values. There are many other methods for dictionaries. If you want to learn more, you can visit that link, w3schools.python/python. It's right there if you would like to know more. So now I'm going to give it to Natalia with functions.
Yeah, we have one last topic to cover, but we're moving on to the most maybe fun part of this workshop, or at least in my opinion, because you can definitely get creative with functions. Functions are blocks of organized and reusable code that is usually used to perform a task. And this is really important because you have to write functions that can be reused with multiple variables. And yeah, you can get creative with this. Functions are defined using the def keyword right here. And just like with the if statements, after we define the function, like after the def keyword, there's the function name with parentheses. The next line of code should be indented so that we know that this code belongs to the function called greeting, right? And to use the function, we can simply call it by stating the name of the function. Yeah, let's run this cell. So in this case, the function's main goal is to print the print the string hello, and it does so, right? We can also put parameters into functions. They're also called positional arguments because, as we will see later, the order of if we're using multiple parameters, the order of the parameters matters. So right here, we're using only one parameter. We're defining the function with the def keyword. The function name is greeting, and we have specified one parameter, which is name. By the way, name is a variable because, yeah, it's a parameter to the function, but it's also a variable. And our function, what our function does is it prints the string hello, my name is, and then the value that the variable represents, right? By the way, if you're have been confused so far as to what those green lines mean, those are comments, and you can actually kind of hide your code if you're using the hashtag in front of a line. So if we just run the function, it doesn't produce, if we just like initiate the function, it doesn't produce an output. But if we call the function and give it and set the parameter to, for example, my name, Natalia, it will produce an output. And the function now says, hello, my name is Natalia. We can do the same thing for Ari, right? So here we can reuse the code by changing the name. And if we don't specify the correct parameters, we will get an error. So if we specify that we need to have a parameter here, and the parameter is like name. When we call the function and we don't specify anything in the brackets, it will result in an error. So what we can do is we can set a default value, just in case this happens. Like, what if what if we don't have an additional name? We always have a default value for this. So when we define a function is the same. Like this function does the same thing. It prints hello world. No, it prints hello, my name is, and then the value that is assigned to the variable, right? But here we can set the variable, the default value of the variable to be Helen. We can do so using the equal sign operator, right? So when we call the function and we don't specify, we don't add anything here in the curly brackets, it will still not result in an error. It will still go through and the string will be hello, my name is Helen. Next, we can also have multiple parameters, and as we discussed before, the order of it matters. So we can have multiple parameters. Here is a similar function. So we define the function. The function's name is intro, and next we pass arguments to the function that we will be using when we call the function, right? So now our parameters are name and role. And what our function does is it prints, hello everyone, my name is, and then it adds the value of the variable name. And then I am the, and it shows the value of the variable role at Baruch AIS. So yeah, and when we call the function, we pass those parameters. So parameter 1 is name. So here I'm going to pass my name. And parameter 2 is role. And I'm going to pass my role at the Association for Information Systems. And here's what we get. Basically, my introduction. Yes. If we, for some reason, confuse the order of the parameters, the output is not going to make sense. So if we specify data science associate as the first parameter, like give it as the first argument, and the first parameter is name, then then this is gonna be the output. So my name is data science associate, and I am the Ariana at Baruch AIS. So yeah, just make sure you have the order of the parameters correct. And we can also have functions return a value that can be used for other uses. Yeah, for example, what if we wanted to create a function that finds the area of the rectangle? We will define the function area. We will define the function, which is called area, and we would specify the length and width parameters, and the function itself should return the product of the length and the width parameters. So it should return a value derived from those two parameters. And then we can assign the function with parameters 5 and 8, which is going to be the length and the width. We can assign this function to variable a. And then when we print the statement, the area is a, what it's going to do here is going to call the function area, right, with the specified parameters. It's just an easy way to reference a function through variables. And the variable is going to be indeed for you. We can also change it to like, we can also change the parameters, so it's like very flexible. And following the same pattern, we can create a function to find the volume of a rectangular prism. But here we're going to have 3 parameters, obviously, length, width, and height. Our function name is volume. There are 3 parameters. First one is length, second one is width, and third one is height. Then the next line of code, make sure to also use indentation. And what the function is going to do is going to return the product of all those 3 arguments. And once again, if we only have those 2 lines of code, nothing is going to happen. We're just going to have a function defined. Like there's going to be no output. But once we, like after we assign the function with the given parameters to a variable, and after we print it out, it's going to actually call the function, and we will have an output, a result. So that concludes our Intro to Python workshop. If you have any final questions, please either enter them in the chat or go off mute and let us know.
I also wanted to throw a reminder out there again, just in case, or if any latecomers did not get it the first time. We are hosting a panel with Accenture next week on Tuesday for AIS. So, and they'll speak about their roles and possibly upcoming opportunities with the organization. Same time as today, 12 to 2:30. So if you are all interested, feel free to hop on for that.
All right. Thank you so much, everyone, for joining this event. We would love to see you again for our upcoming events. This is it. Have a great day.
Yes, thank you so much for everyone who joined. We really love the participation, and we hope that you guys stay connected with us and active. Also, enjoy the weekend. It's Thursday. Coming.
Cool. Thank you guys.
Yeah.
I have a question.
Mm-hmm.
You guys are gonna release the recording for this?
Yep.
We are,
post it
yeah.
on
So
YouTube.
we'll post it as soon as we get a chance to.
Okay. Where is it gonna be posted?
It will
YouTube?
be through YouTube, but we will also have it within our Discord channel as well.
Also, who is recording the event?
It should be Zoom. It's Zoom cloud recording, so it will.
No, like which one of us is doing that?
Yeah, so the cloud records it for us. So it makes all three of, it makes basically any co-host record.
Oh, okay.
Yeah.
Perfect.